Okay, now we are going to talk about one-to-one functions and inverse function. One-to-one function and inverse function. So, one-to-one function and inverse function. Let's talk about one-to-one function first, right? One-to-one function. One-to-one function. So let me give you the definition first, then I'll explain what it is. A function is one-to-one if any two different input in the domain correspond the two different output uh, in the range, right? One-to-one. Whoops. That is, if x1 and x2 are two different inputs of a function f, then f of x1, well, that's supposed to be subscript, is not equal to f of x2. So, just like most of mathematic definition, right? Terms for mathematic definition, this one is also kind of a little bit boring, to be honest, and a little bit confusing, right? So let's try to understand this together. So what they try to do, they try to tell you, they try to define what one-to-one function is all about. Basically, the key idea of this is that if there is a two different input, it'll produce two different output. If it's a different input, it'll produce different output. Then that's one-to-one function. So, x1 and x2 are not the same value, they're two different values. Then f of x1, what is this? This is output from x1. What about this? This is also output from x2. So if you have different input, then you must have different output. That's one-to-one function. It's typical ideal situation, right? We give another illustration. Let's say this is group of boy. Let's say this is group of girl. Let's say there's boy number A, B, C, girl number 1, 2, 3. Right. So if this is one-to-one function, this boy likes this girl, this boy likes this girl, this boy likes this girl. Different boy, different girl. Different input, different output. One-to-one function. One-to-one function, right? Ideal. Now, let's say we have slightly different situation. Let's say this is group of boy, this is group of girl. Let's say you have A, B, C, 1, 2, 3. Let's say this boy likes this girl, but this boy likes this girl too, and this boy likes this girl. Too bad for goal number 2. But, I mean, that could happen, right? Is this a function? Yes, this is function. Is this one-to-one function? No, this is not one-to-one function, but not one-to-one, right? Why? Because to be one-to-one, you have to have different boy for different girl. But look at this right here. These two boys likes the same girl. Different input supposed to produce different output, but different input produce the same output. Then this is not one-to-one case. This is not one-to-one case, right? So one-to-one function means different input and different output. Okay. Now, horizontal test, horizontal line test. Line test. I mean, my handwriting is not the best, but not this bad. You know, this writing pad is just not the best tool to write things. Anyway, horizontal line test is this. If every horizontal line intersect the graph of a function f in at most one point. Then f is one-to-one. Right? That's a horizontal line test. So if you like draw a bunch of horizontal line, and if the certain function intersect only at one point, then it's going to be one-to-one function. You know, for example, let's say you have like this function, let's say it looks like this, and you have another function, say it looks like this. Now you bunch up horizontal line, right? Bunch of horizontal line like that, and same thing in here too. Now if this horizontal line intersect at most one point, now let's check out this horizontal. Well, let's say it intersect here, but what about this line? It intersect here and here. What about this line? It intersect here and here. What about this line? Intersect here and here. So in this case, this is going to be not 1-to-1. What about this one? Well, this function intersects here once. So this is 1-to-1. Right? Simple as that. So you draw a bunch of horizontal line for the graph of a function, and if it intersects on only one point, then it's going to be 1-to-1 function, right? Simple as that. All right, so you get the idea, right? So example, let's do another example. Let's say if you have, say, fx equal x squared, right? You know, this is square function. I hope you remember the shape of this function, like this. Right? That's the shape. So what do you think? This is going to be 1-to-1? Of course not, right? Look at these lines, right? They're all intersecting like 2 points, right? 2 points right here or here. So this is going to be not 1-to-1. Now, what about, say, fx equal x to the cube? Do you remember this cube function? This is one of those library of function, right? Remember that one? I mean, if you don't, you should, right? I mean, maybe I told you before, you know, they say mathematics is based on understanding only. That's not true. That's not true. Half of mathematics is based on memory. You need to memorize certain form, certain format, certain definition, and you know, if you memorize the shapes of this Q function, it looks like this. I mean, it's not, you know, it doesn't really exactly looks like this. It's much more prettier, but you get the idea, right? We draw a bunch of horizontal line. We can see that it only intersect at one point. So this is going to be 1-to-1. 1-to-1 function. So this is horizontal line test. It's pretty neat, I think, at least, right? If you draw a bunch of horizontal line and intersect at only one point, then you consider that as 1-to-1 function. Okay.